Dear students, welcome to our science episodes. Today we are going to continue discussing properties of sound waves. Your ears can distinguish different sounds based on three characteristics: sound pitch, sound intensity, and sound quality. Today we are going to discuss sound pitch. With your eyes closed, can you distinguish between the voice of a lion and a sparrow? The voice of a man and a woman? Yes, of course. The voice of the lion is harsher than that of the sparrow, and the voice of the woman is sharper and softer than the voice of a man. This is a low-pitched sound, the voice of the lion, because the voice of the lion is harsh, low pitch, while this is a high-pitched sound, sounds of birds, because they are sharp sounds. So sound pitch could be defined as: it is the property of sound by which the ear can distinguish between harsh and sharp voices. Look to these two examples. This is a low-pitched sound and this is a high-pitched sound. What is the difference between both of them? Yes, the frequency. Here, low frequency and long wavelength. Here, high frequency and short wavelength. Let's discuss this activity together. You can get a big-sized book, 2 pens, a rubber band, and then tie the rubber band around the book, as in the picture, and insert 2 pens below the band, close to the book edges. Press on the band at a distance of 10 centimeters from one of the 2 pens by the forefinger of the left hand, and then pluck the rubber band by the forefinger of the right hand. Repeat the above step several times, changing the length of the vibrating segment at each time. You will find that the sound of the vibrating rubber band is more sharp when the length of the segment is short, and it is more harsh when the length of the segment is long. So the frequency of the sound waves produced by the vibrating segment changes with changing its length, and the sound pitch depends on the frequency of the sound waves. The sharpness of sound increases as the frequency increases, and the harshness of sound increases as the frequency decreases. Again, low-pitched sound, low frequency, and long wavelength. High-pitched sound, high frequency, and short wavelength. So the pitch and the frequency are showing direct proportional relationship. Now, blowing into an empty bottle produces a higher pitched sound than a full bottle. Why? In this picture, you can find different fluid levels in the bottle. And the question is asking you that when you blow into an empty bottle, this produces higher pitched sound, harsh voice, than a full bottle. Because the less water in the bottle, the faster the glass vibrates and the higher the pitch. The more water you add to the bottle, the slower the glass vibrates, creating low-pitched sound. This means that the air column length is inversely proportional to the pitch. What do you know about Savart's wheel? Savart's wheel is composed of toothed gears attached with a belt to a larger wheel, manually operated. So here is the old model of Savart's wheel. It's composed of a gear with many teeth, a toothed gear with a belt attached to a large wheel manually operated. And it was used to determine the pitch or the frequency of an unknown tone. How does Savart wheel work? First of all, they listen to the tone until their ears get used to it. And then they start rotating the large wheel until the gear teeth come in contact with a metal sheet. They increase the rotation speed until they hear a sound similar to that of the unknown tone. The equation is they used to calculate frequency by dividing the number of cycles or the number of turns by time taken multiplied by the number of gear teeth. The tone produced by Savart's wheel depends on the speed of the rotating wheel, the number of cycles per second, and the number of teeth of the gear. Frequency increases with increasing the speed of the rotating wheel and also the number of teeth. Calculate the frequency of a musical tone similar to a tone produced by Savart's wheel when it is turned 960 cycles in 2 minutes, knowing that its gear has 30 teeth. We know that time in seconds equal 2 times 60 equal 120 seconds. We are converting the minutes to seconds. And then the frequency equal the number of cycles divided by the time taken multiplied by the number of teeth. So 960 divided by 120 times 30, it will give us 240 hertz. That is how they used the Savart's wheel to calculate frequency of an unknown tone. Now it's time for questions. Fill in the blanks. It is the property of sound by which the ear can distinguish between harsh and sharp voices. Pitch. Sound pitch depends on the sound waves. Frequency. The sharpness of sound increases as the frequency increases. The frequency of a sound wave is proportional to the sound pitch directly. Savart wheel was rotated 120 turns in a minute, forming a sound with frequency equal to 100 hertz. Find the number of its gear teeth. Now the number of gears equal to the frequency times time divided by the number of cycles. The number of gears equal 200. 100 is the frequency times time, which is 60 seconds because it's a minute, divided by 120 cycles or turns. It will give us 50 teeth. Thank you. Dear students, thank you for watching. See you later in other science episodes.